Hello. So today we are having a hyperbolic function. Now with the hyperbolic function, we know that if it's our three there, our numerator there is positive, then we know what happens. So let's just say y is gonna be equals to the standard equation a over x plus q. Okay, so the Q is the vertical shift, so it's up and down shift. Then the A is actually what called determine whether our graph is going to be in the first quadrant or in third quadrant or in the second quadrant and fourth quadrant. So for example here, if our A is above 0, we know that it's going to be in the first quadrant and in the third quadrant. So, but if A is less than 0, we know that our graph is going to be in the second quadrant and fourth quadrant. Okay, so that's going to be like that. So here I just simply make it like that. So that's what we will see. So this will be the shape that you guys must understand. And again, our Q now is actually the asymptote. So here, whatever value that you have there is actually an asymptote. We are saying it does not, the graph does not cut on that point. So it's an asymptote. So in this case here, our 2 is actually our asymptote. So that's what you need to pick from there. Then again here, x cannot be equal to 0. So again, x equal to 0 is actually another asymptote. Okay, now what do we need to what do we also see there? We see that we have shifted the graph 2 units up. So we can actually find the x, x-intercept. We can find the x-intercept, but in terms of the y-intercept, y-axis, in this case here, it's an asymptote. So here, our y-axis is an asymptote, and the graph cannot touch the y-axis. Okay, so what we're going to do here, let's look at let's find the x-intercept. So here, intercept our y is equal to 0. Then we have put 0 is equal to 3 over x plus 2. Then we take the x, we multiply with the x throughout. Okay, multiply with x throughout. Then also with x here. Then here is going to be 0. Then it's going to be 2x. So what we have now is that here is going to cancel. So what we're going to have here is 2x is equal to negative 3. So we take there. So our x there will be equal to negative 3 over 2. Okay, so that's where the graph is going to cut our x-axis. So now let's do a quick sketch here. On the sketch, what you already know is that your graph has been shifted upwards by 2 units. So here we have got our x, we have got our y. Then what do we do with the 2? We're just going to come here with the 2, then we put a dotted line. The dotted line is actually showing us our new axis, or our new x-axis. And in this case here, this is our origin, and we are saying the graph will be in the first quadrant, which is this quadrant here. Then also in the third quadrant. Why in the third quadrant? Because of the A that we what I've indicated from the first. So here's a graph. Here's a graph. Okay, that's your graph there. And where is it cutting? It's cutting on negative 3 over 2. So that's what's important there. It's very much important that you you indicate where it's cutting the x, the x-axis or the y-axis. But in this case here, the y-axis, like I said, in your level, you are not going to be shifting your graph or horizontally. It's only vertical shift. So in this case here, y equal to 2 is actually our asymptote. Okay, so let's write here asymptote. Okay, on this case, asymptote, the first asymptote, we know that it's y equal to 2, then actually x equal to 0, because this is x equal to 0, and it can't, attach that line, okay? Then what else do we need to know about the maximum and the minimum? This graph does not have the minimum or the maximum, so you must not worry about that. Then we have the shape. The shape, we see that already see that how it's supposed to be. Then we have the increasing part and the decreasing. So here, let's talk of the increasing. The increasing is when your graph is actually having, I think I've said earlier on, when it's having a negative gradient. So when it's decreasing, but when it's increasing, it's having a positive gradient. So your graph can only have, in this case, you can see, your graph will always have the negative gradient. So when it comes to hyperbolic functions, it's either they are increasing or they're decreasing, just like linear functions. They don't change from increasing or decreasing. So you need to understand that it's either it's increasing or decreasing. So in this case here, it's decreasing because you can see that the graph is actually, it's having a negative gradient. But on the increasing part, that's a no. Okay. So here we don't put it as an increasing. Then I think with the turning point, this graph does not turn. It continuously it continues to approach 2, y equal to 2, and also continue to approach x equal to 0, but never touch it. Okay. So thank you so much. Until next time. Bye bye.